Hello everybody and Happy New Year from PROBAT. My name is Carsten Ehling and I'm the responsible area sales manager for the Scandinavian market. Thank you for joining our first heat event in 2023. This year we will have a lot of interesting topics that drive the coffee industry. And today we have the topic holistic energy management for coffee roasting plants. Therefore, we ask us how to link the former heat sessions, big data and energy efficiency. Our experts today will provide you with valuable insights and into holistic energy management and show how data analysis can be used to employ additional potential. Taking this into account, we try to answer the question, if we start from scratch when planning a coffee plant, what should the setup look like to achieve the best possible results in terms of energy efficiency? As you may know, we started approximately 3 years ago with the construction of our new production facility. And of course, we were confronted with the same question. In the meantime, the project was very successful. As you can see, we are now here in our new production area. At the time of design and construction of the production facility, we worked with our partner, Schönert & Partner, who are specialized in the construction of industrial buildings and also optimization of manufacturing processes. Today, our friends from Schönert & Partner would like to take the chance to share some useful tips and insights together with you. Let's dive into this important topic and enjoy the clip.
Ja, herzlichen Dank für die Einladung. Mein Name ist Tobias Schröders, bin projektleitender Architekt bei Dr. Schönert & Partner. Wir sind ein integrales Planungsbüro aus Köln und haben hier bei Ihnen einen Neubau und die Revitalisierung im Bestand realisiert, der Produktionshallen, und konnten da einige Sachen in Bezug auf Nachhaltigkeit verwirklichen, und ich glaube, deswegen bin ich heute hier. Es ist mittlerweile eine sehr zentrale Fragestellung und auch Planungsaufgabe geworden. Also wir haben gerade in den letzten 3-4 Jahren gemerkt, dass auch die Bauherren vermehrt da einen sehr großen Fokus drauf legen. Ausgehend aus den gesellschaftlichen Veränderungen durch Fridays for Future beschäftigen wir uns damit jetzt sehr intensiv. Wir als Planer aber auch schon etwas länger und auch sehr tiefgreifend mit dem Thema. Und von daher stellt das auch für den Industriebau keine Besonderheit dar, sich damit tief zu beschäftigen. Die Besonderheit ist sicherlich die Bauaufgabe, die wir hier haben. Es sind immer sehr große Baukörper, sehr große Hallen mit viel Fassaden und Dachflächen. Und da gilt es dann natürlich entsprechend für diese großen Flächen ideale Lösungen zu finden, sprich ideale Dämmsysteme, aber auch die Dachflächen effizient zu nutzen, zum Beispiel durch PV-Anlagen. Also da kann man jetzt mal differenzieren zwischen dem Neubau und dem Bestand. Also wir haben einen Anbau realisiert, das ist ungefähr 1/3 von der Fläche der Bestandshalle, insgesamt roundabout 19.000 Quadratmeter BGF. Im Neubau haben wir eine sehr moderne Energieerzeugung und Haustechnik installiert. Wir haben eine PV-Anlage oben auf dem Dach und haben eine Wärmepumpentechnik für die Warmwasser- und für die Heizerzeugung, also für die thermische Energie. Gekoppelt ist das dann mit einem Blockheizkraftwerk, was dann auch gleichzeitig den Bestand mit versorgt. Und für die Spitzenlasten wurde ein Brennwertkessel erneuert, den es im Bestand aus den 80er Jahren gab. Der wurde dann auch nochmal saniert und führte dazu ca. 25% weniger CO2-Ausstoß. Ja, also ich sag mal, auf der klassischen Seite unterscheiden sich wahrscheinlich eine Kaffeerösterei oder dieses Gebäude von anderen Industriebauten nicht sehr deutlich. Also da würde man die klassischen Baumaßnahmen wählen, sprich eine funktionierende gute Dämmung. Auch die Energieerzeugung für das Bauwerk würde man wahrscheinlich dann über nachhaltige und regenerative Systeme machen, zum Beispiel Wärmepumpen und eine PV-Anlage. Eine Besonderheit stellt sicherlich der Nutzen oder das Innere der Fabrik dann dar. Das ist dann dieser Kaffeeröster, der sicherlich eine hohe Abwärme erzeugt aus dem Prozess her. Und da könnte man darüber nachdenken, dann die Abwärme zu nutzen über einen Wärmetauscher, sprich also die Abgase, die Energie daraus zu filtern und das dann entsprechend rückzuführen, zum Beispiel für eine niedertemperatur laufende Fußbodenheizung, die dann das Gebäude beheizt. Auch denkbar ist zum Beispiel eine Wärmerückgewinnung der Raumluft. Das muss man dann halt mal schauen, wie groß das Temperaturdelta dann tatsächlich ist. Man könnte auch darüber nachdenken, diesen Kaffeeröster räumlich zu separieren, um auch nochmal da diesen Effekt der unterschiedlichen Temperaturen Rechnung zu tragen. Das ist aber dann immer im Einzelfall auszulegen, wie groß wirklich diese Abwärme ist und was man dafür nutzen kann.
Thanks to Schönheit and Partner for these advice and insights. So, now let's take the chance to dive into the PROBAT universe. And as you can see, I'm not alone here. Here are my two colleagues, Gökhan and Peter, but I think they will introduce themselves now.
So, thank you, Carsten, and our solution partner, Schönheit and Partner. Those are really important informations and insights that you already shared with us. My name is Gökhan Adamhanoğlu. I'm product manager for controls and digital solutions at PROBAT AG. As I told you that these insights are really crucial for our customers and also for us. So at PROBAT, we are delivering state-of-the-art greenfield project. We did it in the past many times. But today's focus will be, as we already mentioned, that in a greenfield project. As you already know, we are a solution provider for the coffee industry. We are doing that so with our equipment, we're engineering services, we have a consultancy and so on. But we bring on the table our core competence. But we like to see the 360-degree view of our customer's project. Through that, we can support our customers from A to Z. Of course, we have our core competences, and there's also cases that we also seek for support from our partners like Schönheit and Partner. So we have already discussed the possible solutions for the building side of the project. So we would like to talk about okay, which equipment, which ideas we can bring to you guys, and support you with our ideas. You all know every project are unique for us. Every customer's needs are unique, and for that we prepare some examples and to show you where we can save energy, how we can achieve this energy efficient plant for our customers. Therefore, we're sitting here with Peter and...
Yeah, thanks Gökhan. Thanks for introduction. My name is Peter Heinke, a process engineer, working for PROBAT for a long time. And well, in the last years, the focus is getting more and more in energy and consumption. So, yeah, due to the requirements and the concepts of the customers, that it always needs to be supported individually and seen individually. Here I will show an example. Can you make it? Yep.
Hold on a second. Now
Yeah.
you can see that.
Here we have an example just to show you what is possible. In this example, you have a drum roaster, and the first heat recovering system is the recirculation line. You see here, with the recirculating, you have half or 2/3 of the exhaust gas, what is leading back to the roasting system and is covered in the system, and the rest is cleaned by the exhaust gas treatment. The next step is the exhaust gas treatment. You can see here. In this case, it's a Proforte system. It's a recuperative thermal oxidator, and just to explain the principle, roughly, it's you have the exhaust gas, and that is lead through a huge ceramic bed, and in the middle of the ceramic bed you have a very hot zone, and in this hot zone the emissions were cracked. So that means at the end you have clean air is leaving the exhaust gas treatment and will be lead through the chimney.
Peter, one question. How high is the temperature which goes in the Proforte, and how high is the temperature which goes out of the Proforte system?
Yeah, good question. Here you have the normal average temperature of the exhaust gas is, I would say, around 200 degrees, more or less. And in the middle of the Proforte system, you have about 900 to 1,000 degrees, really hot. So everything is cracked, and due to the huge ceramic bed, the heat is recovered back in the system, and at the end you have it's about 250 degrees what is getting out of the Proforte system. That means you have just 50 degrees of temperature increasing in terms of exhaust gas treatment, what is brilliant. Yeah.
Very good.
Yeah. So the next step is here you have a heat exchanger cascade. First there is an air-air heat exchanger, and the second one is a air condensate heat exchanger, which produces a lot of heat power on a low temperature level, but a lot of heat recovery, and it is heating up water that is buffered here in a buffer tank. And with this water, with this hot water, you can preheat or supply your heat exchanger, which are installed here in this examples in the fresh air supports or supplies. In this case here, you have fresh air is sucked for the green coffee preheater. We'll come later on, and you preheat the sucked air on a certain temperature level, and with the air-air heat exchanger, you increase the temperature for the supply temperature here for the green coffee preheating system. The green coffee preheating system is the next step. There you increase or you preheat the green beans, for example, from about 20 degrees ambient temperature to about 80 to 100 degrees, which will shorten your roasting time in the roaster. And that is actually the most benefit, or a big benefit, that you are not just recovering the heat, but also increasing your
production output.
Yeah, production output, right.
Yeah, one question, how much energy can be saved with such a solution? You were talking about heat exchanger, heat recovery, recirculation, and do you have a number, or can you put that in numbers?
Yeah, if you compare this system with green coffee preheating, Proforte, and all these heat recovering regarding the heat exchanger with an not recirculation roasting system and with an ordinary catalytic thermal afterburner, then you can say you save about more than 80% of the heat.
Oh wow, that's pretty much.
Yeah, that's good. Yeah. Yeah.
Another question is, what is the meaning of the arrows down there?
Yeah, I almost forgot to mention. Okay, I'm just here. Here you see these arrows. They are here. You can install or connect your local room air system. That means a room heat system. That means to heat up your manufacturing facilities, whatever. So that means also this is part of the concept, and that is also a good thing. But always
so to heat up room temperature during winter times or something like that.
Yes. For example, the room or whatever. For example, the green coffee preheating facilities. Yeah.
Or if you need some hot process water in your facility, so I think you can also use this hot water in.
Yes, for example, for instance,
for
whatever.
Yeah, definitely.
Yes. So, but always mention that it's that is just an example. So what is possible, but every customer has its own concept. That means. That is absolutely individually configured.
Okay, so there are no limitations regarding the roasting system. It is comparable with all our, let's say, industrial roasting systems?
Yes, right. For every industrial roaster, in this case it's a drum roaster, but it's also for a Jupiter roaster or a Saturn roaster possible. So the green coffee preheater system is universal, and also the exhaust gas treatment is universal, so you can use it for every industrial roasting system. Yeah.
And is it also possible to integrate it if I have an existing roasting plant, or is it only for greenfield projects?
No, sure, you can. Afterwards, even if you have an existing roasting system or installed system, you can upgrade your system and use another exhaust gas treatment, and also integrate the green coffee preheating system. Yeah,
very good.
And also the heat exchanging system. So that is actually common.
The only limitation is then space in this case.
Yeah, sure. That's right. Because you have these. The exhaust gas treatment, the Proforter system is pretty big because of the big ceramic bed, and also the green coffee preheater is more or less a small roasting system, preheating system. Yeah, you need space. Yeah, but if that is available, you can do so.
But not necessarily inside the building, right? I mean, you can also place this. Proforter system outside the building.
Yeah, that is pretty common to put it outside on the roof, for example.
Okay.
Yeah, and actually, when you plan an existing or replan an existing roasting system, so there are always ways to install to find the space for these systems. Also, the green coffee preheater can be installed on the roof, for example.
Oh, okay. Very good.
Yeah.
But then I need some special housing or...
Right.
Yeah.
Yeah.
Okay. Very good. Thank you, Peter.
Yeah.
Nice.
Welcome.
Perfect. I mean, we started with building our facility. It was a building technology. So we started with Schönheit and partners that they provide theoretically the best solution for your facility. In this case, our facility, our production facility, to save energy. And what we are seeing here, or what Peter was explaining, this is the process intelligence side of the project. So now we have a building, we have the best equipment for energy saving and other purposes, but it is not end of the story. So we also have business intelligence. We are not leaving our customer after delivering the facility and equipment. So we are also providing some other solutions for them. For instance, business intelligence. If we are talking about business intelligence, we're at fab scale. We already talked about that many times in different sessions. And so if we talk about optimization, analyzing, and data-driven decision making, we're at a fab scale. So we can provide you some solutions here, because we're thinking of not delivering the equipment or facility. We're also thinking about the product life cycle. We like to support our customers from beginning of the project till end of the product life cycle. So that's why I also brought some use cases. In this case, let us consider that we want to produce product A. And we have in our facility two roasters. It might be the different type of roaster, or it might be the same type of roaster with different capacities. The most important thing here, I'm going to show you some simulations here, then you can see and make decisions supported with the data here. So let me show you the fab scale. As I told you, we already talked about this landing page many times in the past year. And this is our landing page. You can customize that, and you can now directly see, okay, how much energy I'm consuming in my facility. You can see here, per 100 kilogram coffee, you use that much air or electricity whatsoever. If you have 3 roasters connected to fab scale, you can see here in landing page the average value of your facility. But we want to talk about 2 roasters and 1 product. How we can make data-driven decision here. So I will compare reports. So I think, yeah. And I already prepared some template for you. I also recommend it to our customers who is using fab scale product. If you have reporting system all the time, so you can make a template, so you don't have to choose it individually all the time, so you can set it and you are good to go. What we're doing here, we are checking the last week. This is our time frame. And we will talk about the energy consumption and the production time for roaster 1 and 3, and specifically for recipe 102. If I apply filter, I will get this view. This is the landing page for this report. Again, you can see here the average consumption per 100 kilogram green coffee for the chosen recipe and the roasters. But we want to make decisions. We want to say, and we want to compare. For instance, we want to focus on gas usage. I can check it here, and I can see, okay, in average, again, this is the average values. I can see here, okay, how much energy I'm consuming for 100 kilogram green coffee. If you go, scroll down, and we will see different filtering system here per day, but we want to focus on per roaster. Again, this is only simulation. All the values are made up. That's why it is a lot of difference between 2 values. But nevertheless, you can see here, and you can directly make decision with the real data. My roaster 1 is more efficient than roaster 3 in this case. And if you want to use this for board meeting, for some other presentation, or for further analysis, you can save it as PDF, or you can save it as Excel sheet, so that you can use this for other cases. This is only one of the use cases that I can show you here regarding to energy consumption and efficiency optimization. If you have more questions, you can ask us right now. Our chats are online,
Yes,
I guess.
they are open.
You're already checking them.
Yeah.
And if you have more questions, you can write to us at office@fabscale.com, and we are happy to support you also in this case. Thank you.
Yeah, thank you also, Peter and Gökhan, for this very interesting discussion. Of course, this is a very important topic which affects a lot of our customers. And it is good to see that PROBAT is aware of their needs and can provide proper solutions in this regard. Now, come to an end. For me, it was again a very interesting event. And I'm already looking forward to our next event. It will be called Exploring the PROBAT Group of Companies. I look forward to welcome you there again and see you next time. Bye-bye.
Bye.